Hi everyone, welcome to Simplilearn. Today I am going to discuss what is cloud computing, then how we are going to use a Docker in AWS environment. So now let me take you to the agenda of today's session. Today first we'll start with introduction to cloud computing and AWS. After that, introduction to container and Docker. How the containers and Docker are going to be used in AWS environment. So here first question is, what is cloud computing? So cloud computing is storing and using software, data, and services on the internet instead of your personal computer. It's like renting a space and power from a big company's computer so you can access them anytime, anywhere. Even you can say that on demand delivering IT resources over the internet. So whenever you want the resources, you are demanding, you are accessing the resources. And that too, it's pay as you go model. So now if I talk about the one simple example, electricity board. So electricity board, we are not maintaining any infrastructure, but how much we are consuming the electricity, based on that we are going to pay for it. So like that, the cloud computing also, how much we are consuming, based on that we are going to pay for it. Fine. Now let me take you to the next slide. What are the benefits we have if we are using cloud computing? First of all, on-demand access to the computing resources via the internet. So here you can instantly access servers, storage, or database whenever it is needed. There is no any physical setup is required here, right? If I take this simple example, now let us consider I have one developer who is going to launch a EC2 instance. That is nothing but our virtual server on a AWS. So within a minute, you can test a new application instead of waiting a days of a physical server, right? Now, let's move on to the next slide of a benefit. So let me show you the second benefit of cloud computing. So no upfront hardware cost, pay as you go model. How much you are consuming, based on that, you have to pay for it. There is no any advance payment here, right? So you don't need to buy expensive server or infrastructure. You only pay for what you use. How much you're consuming, you're going to pay for it. Now, if I consider one simple example, let us consider I have a startup who uses the Amazon S3 bucket for file storage. And now they are paying only for the actual GB used instead of buying a large amount of drives upfront, right? Okay, now let's move on to the next slide. The next benefit of cloud computing. Here you can see it offers scalability, flexibility, and global reach. So cloud lets you easily scale the resources up or down and deploy your application across the region worldwide. Now, if I take this simple example of e-commerce site, it scale out the auto-scaling group during a scale event to handle a traffic spike and then scale down after the event to save the cost. Now, if I have application where I'm getting a huge amount of traffic in the special events, right? So at that time, automatically the number of resources will be increased. And once the event is completed, then automatically the resources are decreased. That is the power of cloud computing, and that too a feature called scalability, right? And if you want to deploy your application, right, in a one region, and this application will be available around the world, right, within a minute. Let's move on to the next slide, a next benefit of cloud computing. Hosting websites, storing files, deploying applications. Now, cloud services provide all the tools which is needed for hosting, storing, and running applications seamlessly, right? So, if I talk about the hosting website, cloud providers like AWS let you host your website without buying a physical server. You can use the services that automatically handles the uptime, backups, and scaling. If I consider one simple example, let us consider you want to host one static website, whether it is HTML or CSS or JS using the Amazon S3 and CloudFront, right? So even AWS's provision, you can host a dynamic website like our WordPress using EC2 or Elastic Beanstalk as a different compute services. Now, AWS handle the infrastructure setup and scaling for you, right? Let me take one simple scenario here. A travel company hosts its website on AWS S3. So CloudFront will deliver the content globally so user in any country can access it quickly, right? Now, the next part, storing files. So cloud storage service that let you store and access any type of a files. For example, images, video, document backups securely over the internet. It's reliable, scalable, and cost effective. Now, if I take a simple example, using S3, you can upload and store the product images, user document, or backup data. So now the data is automatically replicated across the multiple availability zone for durability, right? Now, if I consider one simple scenario, let us consider I have an app like Google Drive or Dropbox. It uses the S3 to store and retrieve the user uploaded files. Now, if I talk about the next option called deploying application, you can see that one of the feature deploying application. You can deploy, that is nothing but running. You can deploy or run your application directly in the cloud without managing hardware. The cloud providers compute, power, databases, load balancing, and even monitoring the tools to keep the applications running smoothly, right? So if I consider one simple scenario, a food delivery company that deploys its backend API using AWS Lambda. It's a serverless service, right? So now it allows the customer to order food anytime without worrying about the downtime or scaling the issues, right? So folks, these all are the benefits of cloud computing now. Now, let's move on to the next slide where I'm going to discuss about types of cloud: public cloud, private cloud, and hybrid cloud. So now let me discuss what exactly the public cloud. So public cloud is owned and operated by third-party cloud providers like AWS, Microsoft Azure, or Google Cloud. So here all computing resources, server, storage, and networking are shared among the multiple customers, but each customer data is isolated and secure. Let me take one simple example. A startup hosts its website and database entirely on AWS services. They don't own any server. They just pay AWS for what they use, right? Now, if I talk about the real world example, Netflix uses the AWS public cloud to stream the content to millions of users worldwide, right? Now, let me take the next point, a private cloud. Private cloud is used by single organization. It can be hosted on premises or in data center, but it's dedicated only to the organization, which offering a more control, customization, and security. Now, let me take one simple example here. A bank runs an internal application and sensitive customer data on its private cloud, but built using a VMware or OpenStack within the data center. If I take one simple real-world example, for example, we have a government departments which often use of private clouds for handling confidential data, right? Now, the third type is hybrid cloud. So now, as the name itself indicate, hybrid, the combination hybrid cloud which combines the both public and private clouds here, right? Which allowing a data and application to move between them, right? So here it gives a flexibility. Organization can keep a sensitive workload in a private cloud and use the public cloud for less sensitive or high demanded tasks. Now let me take one simple example here. A hospital stores a patient records in a private cloud for security, right? But it uses the public cloud like AWS to run the analytics or a host public website. Even if I take one real world example, airline, right? Airline often uses the hybrid cloud. Ticket booking system is in private cloud to secure data, right? And the web application on a public cloud always available, right? So this is all about different types of cloud available in cloud computing concept. Okay, now let's move on to the next slide where I'm going to discuss about introduction to AWS and key services. Now, you can see here AWS, Amazon Web Services. It's a cloud computing platform that provides on-demand access to IT resources such as compute, storage, database, and networking over the internet with a pay-as-you-go pricing model. Even it allows the companies to build, deploy, and scale applications globally without maintaining physical hardware, right? So now this AWS provides more than 200 services, more than 200 AWS services, right? Here, let me show you the next slide. In that you can see some of the compute services which are available in AWS. So there are lot of compute services we have in AWS environment. In that you can see on a screen EC2, one of the popular compute service, and the another one is AWS Lambda, right? So now when I'm talking about the EC2, Elastic Compute Cloud, right? It provides a virtual server, and in AWS environment we are calling it as an instance, right? So why we are using these instances? To run our application. So now you can choose your CPU, memory, storage based on your needs, right? Now let me take one simple example. A simple example. You can launch one EC2 instance to host a company website or an application. If your website traffic increases, you can add more instances using autoscale, right? Now, if I talk about the AWS Lambda, Lambda is also one of the popular compute service, but AWS Lambda is serverless compute service that runs your code automatically when triggered. So no server to manage. You pay only for the execution time here, right? So this Lambda is one of the serverless service. Serverless means everything will be taken care by AWS, right? Provisioning, updating, patching, everything will be taken care by AWS. Now, let's move on to the next slide. A next core service called storage services. So now AWS provide the different storage services. Now you can see Amazon S3. S3 stands for Simple Storage Service. Amazon EBS, Elastic Block Storage. Then we have Glacier, Amazon Glacier, right? So first, Amazon S3 is one of the object level storage for storing files, images, videos, backups, and even static websites. It's highly durable and scalable storage service. Now let me take one simple example. If I want to store the user uploaded profile pictures or a website static content in a S3 bucket, at that time I'll go with S3 service, right? Now the second type is called Amazon EBS, Elastic Block Storage. So it's a block level storage, right? So now a block storage for a EC2 instance. It's used like a hard drive for storing operating system files, logs, or databases. Now if I take one simple example, let us consider I want to attach one EBS value to EC2 instance to store your web server's application files and databases, right? Now, the third option, Amazon Glacier, right? So this is also one of the low cost storage for data archiving and backup purpose, right? And these Glacier are rarely accessed and the retrieval can take a minute to hours. That's why we are using for a special use cases. For example, let me take one simple example here. A company stores old financial records or yearly reports in S3 Glacier for long-term retention. At that time, you will go with Amazon Glacier service. Okay. Now, let's move on to the next core service called database services. So in AWS environment, there are different types of databases are available. As per your client requirement, as per user requirement, you can select your own databases. Here, the first one you can see RDS, Relational Database Service, DynamoDB, Elastic Cache. So now you can see here RDS is fully managed service, fully managed relational database service such as MySQL, PostgreSQL, Oracle, SQL Server. The different database engines are supported in this RDS service now, right? Now, if I take one simple example to explain this RDS, let us consider a shopping app which uses the Amazon RDS MySQL to store user and order data, right? It's a fully managed service. It's a fully managed service. Everything will be taken care by AWS, like handling the backups, updating, scaling, everything will be taken care by AWS. Now, the next part, DynamoDB, right? DynamoDB is also fully managed NoSQL database that provides fast performance automatic scaling, right? So DynamoDB, it provides a single digit millisecond response to the customer. That's why we are using, if I talk about the examples, we are using in real-time gaming application, which uses the DynamoDB to store player scores and session data for millions of users in real time, right? Now, let me take you to the next database service called Elastic Cache. Elastic Cache is in-memory caching service, a special database, open source database engines called Redis and Memcache, which is used in this Elastic Cache, right? So now, by using this Redis or a Memcache, it speeds up the database query by storing frequently accessed data in memory, right? Now, if I talk about the simple example, let us consider I have one e-commerce site which uses the Elastic Cache, right? Now, it catches the product details. It reduces the database load and even it improves the performance also. Now, let's move on to the next core service called networking services. So, in AWS environment, there are different types of networking services are available. So, in this slide, you can see a few services like Amazon VPC, Amazon Route 53, and AWS CloudFront. So, Amazon VPC, Virtual Private Cloud. So, actually, it allows you to create a private network inside AWS, where you can launch the EC2 instance, define the subnets, and control a traffic using a security groups. If I consider one simple example, let us consider one company creates a VPC within a public and private subnets. So public for web servers and private for databases, right? Now, the next service is called Amazon Route 53. So this Route 53 is a DNS service in AWS environment, a domain name system. It's a web service that routes a user to websites using the domain name. Let me take one simple example. For example, now I am going to register a domain name like myshop.com in Route 53. Now, which routes a user to your EC2 instance or ES3 hosted websites. Fine. The third service is called AWS CloudFront. CloudFront is nothing but it's a content delivery network service that catches and deliver content to the user globally with low latency. So what kind of a content? Like images, video, website, it provides to the customer or a user or a client with low latency. Let me take one simple example. A streaming platform uses a CloudFront to deliver the videos quickly to the user worldwide by caching them at the edge location, right? So these all are a networking services which is provided by AWS. Okay, now let's move on to the next topic called overview of AWS global infrastructure. So in this global infrastructure, I am going to discuss what is region and availability zone. So region is a geographical area where AWS has a multiple data centers. Even you can say that region is nothing but it contains the AWS resources, services which are available for you, right? Each region operates independently with its own set of AWS services, pricing and compliance rules, right? So region help you to place your application close to your user for better performance and meet the data residency requirements, right? Now, if I talk about the global infrastructure, right now in AWS, we have 38 regions, right? Let me take one simple example, like AWS has a region like US East, North Virginia, Asia Pacific, Mumbai, Europe, Frankfurt, right? So if most of users are in India, you can deploy your application in Mumbai region to reduce the latency, right? Now, let me take you to the next point called availability zones. What exactly the availability zone? each region contains multiple availability zones, that to minimum 2 and maximum 6 availability zones we have, right? So availability zone is basically one or more data center with separate power, networking and cooling, right? These availability zone within the same regions are connected by high speed low latency link. So using this multiple AZs, you can make your application highly available, fault tolerant. If one AZ goes down, the another can take over, right? Now let me take one simple example. Let us consider in Mumbai region, AP South has a 3 availability zone. AP South 1A, AP South 1B, AP South 1C. So now you can deploy your web server in AP South 1A and your database in AP South 1B. If one AZ fails, your application remains online, right? So right now in AWS Global Infrastructure, total 120 availability zones we have. Yes. Now you can see I have one page called AWS Global Infrastructure. It's an official AWS page which is provided by AWS for a global infrastructure related information. Now you can see here, as I discussed before this, total we have 38 regions and 120 availability zones, 700 CloudFront edge locations, point of presence, right? 43 local zones and 31 wavelength zones right now, which is available in AWS infrastructure. If you see here in this map, these dark circles which indicate the available regions like Canada Central, right? US East, Northern Virginia, like this. You can see there are multiple circles are available around the world. And this AWS European, right? This is upcoming region. You can see here the dark circle which indicate the already available regions. If you see another type of a circle which indicates upcoming region like AWS is going to launch a new region. Fine. As I discussed just now in AWS Global Infrastructure page, total 38 regions we have around the world and 120 availability zones available around the world. Now, let me show you the next slide called edge locations. So, edge locations always caches the content near to the user. Edge locations are the AWS data centers located closer to end users than a region or availability zones. So, always these edge locations are used by CloudFront Content Delivery Network and other AWS services to cache the content and deliver it faster with low latency, right? Now, in this diagram, you can see here I have client, right? There are multiple clients are available. And this is the origin. Origin is a place where exactly your files are exist, right? So first time when you request any file, it takes from the origin. Then it copies the content in this content delivery network. When the second time asks the same request by the multiple client, instead of going to the origin server, the response will be provided from a CDN, content delivery network. So by doing this, we are reducing the latency and improving the performance. Why? Instead of going to the origin server, the results will be provided from this content delivery network, right? Now, let's move on to the next slide, high availability. So here in AWS infrastructure, if I want to make my applications highly available, right? So my application should be deployed in multiple availability zones, right? What exactly it means? Keeping your applications running continuously, even if part of the system fails. AWS achieved this using multiple availability zones and auto-scaling. Let me take one simple example. Let us consider I have one web applications which runs in 2 different availability zones within a Mumbai region, right? If one AZ called AP South 1A goes down, traffic automatically shift to AP South 1B. So user don't face any downtime. Okay, let's move on to the next slide where I'm going to discuss about global network. So global network, AWS has a global infrastructure consisting of region, availability zones, and even edge locations, which are connected by a AWS private backbone network. Even it ensures the fast, secure, and reliable data transfer across the world with low latency and reliable connectivity. Let me take one simple example. Let us consider company applications deployed in Singapore region can securely communicate with the backup system in London region using a AWS private global network, not the public internet, right? Now, the next point in global infrastructure is data residency options. So, this data residency refers to the geographical location where your data is stored and processed. Some of the organizations or countries requires a data to remain within a national boundaries. So now AWS lets you choose the region to meet the legal or compliance requirement. Let me take one simple example here. Let us consider an Indian bank stores a customer data only in Mumbai region to comply with India's data residency laws. Right? Now, the next point you can see IAM overview. So here you can manage access to AWS services securely using users, groups, and roles. So let me give a clear picture about this IAM. IAM stands for Identity and Access Management. It's a service that controls who can access AWS resources and what action they can perform. Even you can create users, groups, and roles and assign the permission using policies. Let me take one simple example. You are creating a IAM user with the name called developer1 and give the access only to S3 and EC2, not RDS. That means a developer1 can access only S3 and EC2 machine, not RDS databases. Okay, now let me take you to the next slide, that to a granular permissions. So control access with fine grained policies defining allowed actions. So IAM allows a fine grained granular access control. So you can specify exactly which actions a user can perform on which resources. Let me take one simple example. A policy allows a user to upload to an S3 bucket but not to delete a file, right? So the user can store a file but can't remove that. It's all about a granular permission, right? Now, let me take you to the next slide called multi-factor authentication, right? So MFA, multi-factor authentication, adds an extra layer of a security beyond passwords. It requires a user to provide a second authentication factor like a code from a mobile application or a hardware device, right? Let me take one simple example. When you try to sign in to the AWS console after entering password, you also enter a 6-digit code from the AWS MFA app on your phone. So once you provide that MFA code, then only you are able to access the AWS services, right? Now, let's move on to the next slide where I'm going to discuss the point called temporary credentials. So when we are talking about the temporary credentials, the first term comes into the point called IAM roles, right? So these temporary credentials, instead of giving a permanent credentials, AWS can issue a temporary access keys with a limited lifetime. So let me take a service called IAM role. IAM role is a temporary service where you can customize the duration from 1 hour to maximum 12 hours. This is secure short time access, right? So IAM roles are specially designed for temporary access. If I talk about the example, a cross account access. If I want to access from one account to another account, access the resources at that time. If you want to provide access, you can use the IAM roles. Let me take one more example. Let us consider I have an application which is running on EC2, assumes a IAM role and get a temporary credentials to access the S3 bucket for only 1 hour. So it's up to you. You can customize from 1 hour to up to maximum 12 hours, right? Now, let's move on to the next point called integration. So now these services are integrated with other AWS services. It works with corporate directory, federated identity providers. That means where you can manage the users, where some of the third party users. For example, if one of the person who is outside the organization, if he want to access the AWS resources of your organization, at that time identity and federation which provide the access control. Once the user is successfully authenticated, then only the user can access the AWS resources. Okay, so now what are containers and why containers are required? So containers are lightweight portable package that bundle an application with everything it need to run, like code, libraries, dependencies. They ensure the app runs in the same way on any computer, whether it's your laptop, a server, or the cloud, right? So now this container is a lightweight, standalone, and executable package that includes everything which is needed to run your application, like code, runtime, libraries, dependencies, everything, right? So container ensures your applications runs in the same way everywhere. For example, on developer's laptop, testing server, or even in a production environment, because they package everything together, right? Now, let me discuss some of the features of containers. So now the first one is lightweight standalone executable package. So when the term comes lightweight, container shares the host operating system kernel. So they don't need to include an entire operating system like our virtual machines does. This makes them a smaller in size, that too from MB to GBs, right? If I compare what MB versus GBs, that is the reason it's faster to start. Even it include just what necessary for the application to run. Because of that reason, it make them portable and efficient, right? Now, if I take the example of a Docker image for Python API, might include a Python runtime engine, application code, and even some of the required libraries like Boto3, Flask, and even more. So now, these images can be deployed anywhere, locally, or even there is a container service called ECS, Elastic Kubernetes Service, right? Now, let me take you to the next feature called run consistently across environments. Now, they eliminate the works on my machine problem, standardizing environment. So now, run consistently across the environment. Containers are isolate the application and its dependencies. So the environment doesn't change across the stages. Whether it's your local laptop or a test environment or a production on an AWS, the behavior remains identical, right? So by doing this, it reduces the bugs caused by different software version or missing dependencies, right? Let me take one simple example. A developer can create a Node.js application and packages into the container image. So now the same image that runs successfully on even in your own laptop, Docker desktop using a Docker desktop software, or in AWS environment, we have a service called Elastic Container Service for testing purpose, and even AWS Fargate for a production purpose. There is no environment differences cause issues here. Now, let's move on to the next feature of a container. Faster boot time compared to virtual machines. So container starts in a second because they share the host operating system kernel. So virtual machine require the booting an entire operating system before starting an application. Containers only start the application process because they share the operating system kernel. So they boot in a seconds. So this allows a rapid scaling. You can launch or replace the containers quickly based on demand. Now let me take a simple example. During a traffic spike, there is a service in container called Elastic Container Service, which launches a new containers in a second to handle a more web request. once the traffic drops, AWS automatically terminates unused container to save the cost. Right? Now, let me take you to the next feature of container. Ideal for microservices and CI/CD pipeline. So CI/CD stands for continuous integration, continuous deployment, right? So here, instead of one large monolithic application, container makes easy to split your application into smaller independent services called microservices, right? Each microservice runs its own container, which is easy to deploy, scale, and update individually. So this makes the system more resilient. If one service fails, other keeps running, right? So if I consider the simple example of e-commerce application. So e-commerce application may have card services container, payment services container, inventory services container. So all deployed using ECS service to communicate through APIs. So this part is all about microservices architecture. Now, if I talk about the CI/CD pipeline, so containers integrates easily with continuous integration or continuous deployment CI/CD tools. So you can build or test, and even you can deploy the container images automatically using, there is a service called AWS Code Build, Code Pipeline, or GitHub Actions. So now this leads to a faster delivery and version control of your application. Now, if I take a simple example, when a developer commits a code to GitHub, in that situation, first code build service, which creates a new container images, ECR service, Elastic Container Registry, which stored the images, and ECS automatically deploy the new version into production, all within a minute, right? Okay, now let's move to the next topic called Docker. So now, what are Dockers? Docker is a platform that makes it easy to create, run, and manage containers. So think of it as a toolkit that helps developer package application into containers, so they can run consistently across a different environments. So now, Docker is one of the most popular containerization platform. It provides tools and commands to build your container from application code. You can shift the images to repositories such as a Docker Hub or ECS service. Even you can run a containers on any system that supports Docker, right? So now this Docker standardizes the container format and makes it easy to manage your application lifecycle. Now, let me take one simple example, right? A developer uses some Docker build to create the image of Node.js web application, and then it push it to the Docker Hub, and then you are going to run its own AWS EC2 instance using Docker run command, right? If I take one simple scenario, let us consider in an organization we have DevOps team who uses the Docker to containerize 20 internal applications. So with one standard tool, deployment becomes a predictable and fast, saving an hour per releases here. Now let's move on to the next part of a Docker. So now Docker as a container platform. So now Docker, it simplifies a 3 key stages of container lifecycle. First, building, then second, shipping, and third, running. So when it comes for the building, it creates a container images using a Docker file. Then shipping, it push the images to repositories such as Docker Hub or Elastic Container Registry. Then the third option is called run, where it can launch the container from images. So now Docker provide the Docker engine, CLI, and Docker composes for multiple container setups. Let me take one simple example. Now let us consider you are building one application using Docker build, right, which stores the Amazon ECR, right? And then you are going to deploy using the AWS Fargate, which runs your container without managing EC2 service. Fine. Now, let's move on to the next part called app packaging. So here you can see application and dependencies are bundled into portable images. So Docker packages everything your application needs like code, framework, libraries into a single image file. So this eliminates the dependency conflicts and make deployment faster, right? Let me take one simple example, right? Let us consider I have one Flash web application with Python dependency where I have Flash, Boto3 and request, which is bundled into the Docker image. So now this particular application will run identically in AWS ECS service, regardless of what Python version of the host has. Fine. Now let's move on to the next feature called versioning and reuse. So Docker images are version controlled and can be reused easily. So now developer can add versions and even they can roll back to the previous ones and share across the teams, right? Let us consider I have the application, my application version 1, version 2 and my application latest. Now, if V2 fails in a production environment, so DevOps can quickly redeploy into V1, right? Now, let me take a simple scenario. Let us consider we have CI/CD setup, continuous integration and continuous deployment setup. Every code that push builds a new image versions. So now AWS code pipeline uses the latest image tag to automatically deploy the new version while keeping old ones for a rollback, right? Now let's move on to the next point of a Docker Hub. So here you can see central repository and container images. So Docker Hub is a public cloud-based registry where developers can upload a container images, that is nothing but pushing the images, download a existing one, that means pulling the images, and even you can share the images with others, right? So it hosts official images like Nginx, MySQL and even Python, which serves as a trust-based images. Let me take one simple example here. Now you pull Nginx from Docker Hub using a Docker pull Nginx. Then you deploy it as a web server container. Now let me take one simple scenario. A startup uses a Docker Hub to store and share its base application images across team in a different countries, right? So here that is the reason how we are going to use this repository as a hub, how we are going to use this Docker Hub with the multiple versions. Now let's move on to the next part of Docker container, where I'm going to discuss how we are going to build and run a Docker containers. So now building a Docker container, it creates an image of your application with all the required files and settings. Even running it starts that image as lightweight isolated environment where the application can run consistently anywhere. So now this building creates an image that is nothing but a blueprint, while running starts a container, the actual process. Now container runs isolated from the host system but can communicate through a exposed ports, right? Let me take one simple example here. For example, the command is docker build -t my application version 1, and then you are going to run docker run -d -p ap80 as a port number, then your application version 1. So this builds and runs your container application accessible on port number 8080, right? Now let me take one simple scenario. Let us consider we have a developer who is going to test a new API locally by running its Docker container before deploying it to AWS ECS service, right? Now, in the next slide, you can see how we are going to create a container from the images. So Docker has become a de facto platform for containerization worldwide. So now one image in this particular slide, you can see one image can create a multiple containers. This makes it easy to scale application horizontally. Multiple copies of the same application can handle more users. So now if I take a simple example of a command called docker run -d my application version 1. That means it runs 5 times and it creates a 5 container. Each container serves users traffic in a parallel, right? So what will be the scenario? Let us consider now I have one streaming platform, right? Streaming platform that runs at 20 identical containers from the one image across the EC2 instance to handle millions of concurrent viewers, right? Now, let's move on to the next point called Docker file. So, Docker file is a script that specifies how an image should build. Even you can say that a Docker file is an instruction file that defines how to build your image, including a base image, application code, dependencies, port number, and even command, right? And even it ensures that repeatable and automated builds, right? So there are multiple Docker files we can create here, like from where, which particular word directory, what copy command I can use, how I can run, and even what kind of a command I can use to run my server particular Node.js, right? So now let me take one simple scenario. Every time developer push a code to GitHub, right? So using AWS code build, automatically it reads a Docker file and builds a new image and then it pushes to the ECR service, right? This is one of the scenario you can consider how this Docker file can be used in the environment, right? Now, let's move on how we are going to run a containers, right? So, there is a command called docker run where you are going to launch the container from a images. Now, you can specify which port number, right? So, you can specify that ports to expose and values to mount, even environmental variable, that everything you can specify here. And even there is a detached mode where you can use -d. Let's container run in the background, right? So for example, let us consider I want to run the container. So the command will be docker run -d -p at nginx. So it runs a web server in the background. Now, if I consider the simple scenario, let us consider in my organization, I have a DevOps engineer who quickly spins up a containerized Nginx instance on EC2, which hosts to test our load balancing configuration, right? Now, after that, how we are going to manage a containers, that I am going to discuss in the next slide. So how we are going to manage these containers? We have multiple commands like docker ps, docker logs. Docker ps means it can list a running containers. So Docker provides the command to monitor, stop, and even remove containers, right? So like that, Docker ps is for list the running container. Docker logs and ID if you want to view the logs. Docker stop along with the ID, you can stop a container. Docker rm with the ID, you can remove a container from the list of containers. So these commands are vital for troubleshooting and lifecycle management. Now let me take one simple scenario, right? If a web container crashes, the engineer checks the log using Docker logs, right? Then it fixes the issue and relaunches the new container from the same image. Okay, now let's move on to the next part where I'm going to do a comparison with Docker images and containers, right? So here Docker image what is container we are going to discuss in this particular slide. So Docker image is nothing but it's a blueprint or a template. It defines what inside your container is, like application, libraries, operating system dependencies, etc. Right? So now Docker container is a running instance created from the image. So you can think of the image as the class in a programming terms, right? And the container as an object. So one image can launch a many container, each isolated but running in the same application. So always images are static and containers are dynamic. They can start, stop, or be deleted anytime, right? Now let me take one simple example. So now you are building a Docker image called My Web Application 1 or My Web Application version 1, which contains your Node.js web application, right? Now you are going to run it using a Docker, right? So Docker run -d -p at then My Web Application version 1. So now a live container is created and serving your website, right? Now let's move on to the next slide here. Docker images. As you can see, these are read-only template. So Docker images is a read-only snapshot built from a series of layers. Each layer adds something like code, dependencies, or configuration. Once built, it cannot be changed. This is immutability, which ensures the reliability. So images are created using a Docker file and stored in a local system or repository like our Docker Hub, which is public. And Amazon ECR, Elastic Container Registry, is a private cloud registry now, right? Let me take one simple example. Let us consider I am building one Python image. So at that time, Docker build -t my Python application version 1. So now by using this particular command, my Python app version 1 becomes the reusable and read-only images. Fine. Now let's move on to the next point, containers. So here you can see running instances, daemon and application, right? So this container is a running instance. Container is a live, isolated process which is running from a Docker image, right? It has its own file system, CPU, memory, and even network namespace, but share the host operating system kernel. So each container runs independently and can be started, stopped, or deleted anytime. And these containers are stateless by default. So data is lost when they stopped unless the volume is attached, right? Now let us consider I want to run, right? So Docker run -d -p 5000 as my Python app version 1. So now you are running a container service, your application at the http:/localhost:5000, right? So how exactly the running instance work here? Now let me take you to the next slide where you can see a single image, one image with multiple containers. So now single image can be used to launch multiple containers. Each container runs independently but uses the same base image. They support the horizontal scaling that running a many identical instances to be handle the load, right? Now, if I talk about the example, you can run the command docker run -d -p 8081, 8082, 8083 with the 80 my web application version 1, version 1, version 1. So now automatically the three containers running from the same image which serves the traffic simultaneously, right? So just now whatever the commands just now I discussed, how to run your Docker container and even how to delete a Docker container, how to check the logs, these all commands I'm going to run in AWS environment, that too in a Docker, right? Even just now what I discussed, how a single image can be used with the multiple containers, right? docker run -d -p 8081 colon 80 my web application version 1. Like that, I am going to create a 3 containers using from the same image. I can serve a traffic simultaneously, right? So like that, even I am going to do some hands-on related to a Docker images, how we are going to use in a AWS environment, right? Now, let's move on to the next point called isolation. So containers are isolated from each other but share the operating system kernel. So container, no doubt, containers are isolated environment. Each has its own file system, processes, network interface, but they share the host operating system kernel, which makes them more lightweight than virtual machines. Even isolation, it ensures that one container crash doesn't affect others, and even security boundaries are maintained. Now, let me take one simple example. Let us consider you have a container A, MySQL, and container B, web server. Even if MySQL crashes, the web server keeps running. Let me take one simple scenario. In AWS, we have a service called EKS, Kubernetes on AWS. Each pod, that is container group, which runs isolated from others. So now developers can safely deploy the different microservices on the same cluster using the interference, right? Now, let's move on to the next point called ephemeral by nature. So here, containers are disposable and designed to be replaced, not fixed. Now, containers are temporary, designed to be replaced, not to repair. So when container stops or fails, you typically launch a new one from the image instead of fixing it manually. So this makes containers stateless and ideal for auto-scaling and immutable infrastructure. Even you can say that containers, if persistence is needed, you have to attach the value as an external storage. Let me take one simple example. I have a Node.js container with serving a user's fields, right? So Node.js container serving user fields now. So ECS will automatically start a new container from the same image in a second. Let me take the scenario. I have one AWS ECS service and health checks are continuously monitoring the containers. If one fails, AWS will automatically replace it and ensure the high availability. So for stateful data, the containers uses EBS volume or S3 to persist information, right? So this is all about how we are going to use these containers, right? And that too, these containers are designed to replace, not for repair, right? That's why we are calling it as containers are temporary in nature, right? It is designed to be replaced, not repair, right? Okay, now let's move on to the next part where I'm going to discuss about Docker commands hands-on, where I'm going to discuss how to check the Docker installation, then how to pull a pre-built images, how to run a container, how to list the running containers, how to stop the containers, and how to build your own images, right? And even here, I'm going to show you some of the commands like Docker build, where I'm going to create an image from Docker file for reuse. Now, a Docker build is a command where we are going to create the images from a Docker file for a reuse. Next, we have another command called Docker images. So using Docker image, we can list all the images available locally on the system. The next, we have Docker run. Docker run is a command that starts a container from an image with defined parameters. Then Docker execution. Docker execution, it allows you to run the command inside a running container, right? The next, we have Docker stop or remove, RM, where I can use this command to stop and clean up container once no longer needed. So now I am going to show you these all commands in AWS environment with hands-on. Okay. Okay. Now you can see here. Okay. Now let me demonstrate how we are going to install a Docker on my EC2 machine. So first, let me launch one EC2 instance. Click on launch instance. And let me provide the name called Docker server, right? So I'm going to use a Linux operating system with AMI Linux 2023, right? And the instance type is t2.micro, right? So keep here without keep here. Then here I'm going to allow the SSH, HTTPS and HTTP traffic to connect my EC2, right? After this, let me launch the instance. Now you can see my EC2 instance is successfully launched, right? So Docker server is successfully running now. Let me connect this Docker server by using this connect option, and I have EC2 instance connect option. Click on connect. Yes, now you can see I have successfully connected with my EC2 Linux operating system, right? So now you can see EC2 user with the private IP address of my EC2 machine, right? So first, let me take you to the super user where I'm going to install first Docker, right? So the command what I'm going to use install docker -y, right? So let me remove this, right? So install docker -y. You can see here the first command what I'm using install docker -y. It installs a Docker engine on your system. You can see the progress, how it's installing. Yes. Now you can see successfully Docker engine is installed on my EC2 machine. Now I'm going to enable the Docker to start automatically when the system boots. So for that, I'm going to use the command called systemctl enable Docker, right? Yes. Then next, I am going to start start the Docker service right now when I'll put this command. Let me put the start command, right? Okay. So this demonstrates my Docker service is right now active, right? Even if you want to check if Docker is currently running or not, you can use the command called systemctl is active Docker. So the result should be output should be active if it is running. Now you can see it's showing active. That means my Docker is active now, right? Even this is the procedure to check whether my Docker is currently running or not, right? And even here you can check if the Docker is enabled at boot or not. So for that you have to put the command systemctl is enabled Docker. So output should be enabled if your Docker is enabled. So now you can see the result is enabled. Now the next command, I'm going to check the Docker version and its information. So for that I required a command called docker -version. So now you can see a Docker version 25.0.13. You can see the version of a Docker, right? Now let me consider the next information called Docker info, right? Docker info. Now you can see the detailed information. It displays the system-wide Docker details like number of containers and images, storage drivers, C group drivers, operating system version, kernel, etc. Right? Now let me take the next command called docker help. So docker help command, it lists all the Docker commands. It lists all the Docker commands and their usage. Now, I'm going to search for the images on a Docker hub, which is officially image registry. So for that, let me use a command called docker search nginx. Yes, docker search nginx. So now you can see I'm done with searching nginx. Let me take with Redis also. Let me take you to the next command for Redis. Right? This is for Redis, and same thing I'm going to use for MySQL and then BusyBox. Another one, I'm going to search for the image called BusyBox. Right? So these are the images successfully searched from the Docker Hub, which is official image registry. Now, after searching, now I'm going to pull, or you can say that download these images locally so it can be used for a containers. So for that, first I have to use the command called docker pull nginx. So now let me put the command. Yes, you can see here a image is successfully downloaded in a local machine now in my EC2, right? Same thing for Redis, docker pull Redis. A same command I am using here for Redis. Then I am going to use for my MySQL, what I searched for the image. Next for MySQL, right? Then next, okay. Now let me take the next command for BusyBox, docker pull BusyBox, right? So this completes downloads, or you can say pulling the images, right? Now I'm going to create and run a Docker containers. So a command to create a container named called container1 from the nginx image, but does not start it. So now let me paste a particular command here, docker create name -name container1 nginx. So now it creates a container name called container1 from the nginx image, but does not start it, right? So next, what I'm doing, I'm going to start this container. So just now what I created the container, I'm going to start that container now, right? So container1 is started, right? Now let me list out now by using a docker ps. Yes, you can see here nginx image is available with the container id, the last 40c2 as a value. Now let me stop the container. So for that, docker stop container1. So now you can see a container1 is successfully stopped. Okay. Now I'm going to create a container. Even you can say that where I'm going to combine a creating and start, right? So let me use the command called docker run -i t -d -name and continue container1, right? So -i, it's interactive, t to assign the terminal, d is nothing but detach that container, right? Now, yes, I'm done with first part, right? Now let me take the next for nginx, right? So the next I'm going to combine and create then start. This is for my second container, right? And same thing for my Redis, docker run container3 Redis, right? And then for we have MySQL. This is for MySQL image, right? And then finally we have a BusyBox. This is BusyBox now. So it runs containers directly in detached mode, that is -d, and interactive terminal, that is IT. So what exactly this meaning of this flags? Minus like -i keep standard in out, then -t allocate the terminal, -t allocate the terminal, and -d run in background. Then next, let me take the next command for pulling the image. Okay, now I'm going to check how many number of running containers I have and how many number of stopped containers are presently available. For that, let me use the command called docker ps, where I'm going to see all the running containers. So here you can see busybox, Redis, and Nginx, right? Now, let me show you all the container which is running, stopped, and even exited also. For that, ps-a -a, you can see here busybox, MySQL, Redis, Nginx, all the images right now present available in this Docker container. Now, let me show you how I am going to stop my container 1. So for that, docker stop container 1 I'll use. So now you can see container 1 is successfully stopped. And now if you want to start your container 1 again, so at that time you have to use a command called docker start container 1. So now again your container 1 is start. Now let me show you how we are going to remove a image, Docker container image from a Docker repository. Now type a command called docker, right? rm docker remove, and here you have to specify the container ID. Let me take Redis. Let me specify with a docker rm command, docker rm, and here is the container ID for Redis, right? Let me copy this and then paste here, right? So now you can see docker remove. I am using the container ID, right, to remove this Redis from the list. So here, so now you can see there is an error. This particular command I am using purposely. Why? Because before removing any container image, you should stop. Again, I am repeating, before removing any container image, you have to stop that, right? So here you can provide this container ID, which is for Redis, right? So now this is successfully stopped now, right? So now you can remove. So you can see here successfully your Docker image is removed, right? Let me show you while listing, right? Docker -a. So here you can see Redis, a Docker, like a container ID of a Redis image is successfully removed from this Docker repository. Now, I am going to discuss some of the commands, like how we are going to use the container logging and interactive access. So now you can see docker run -d -8 name container 6 Redis win sh while true and do echo hello all I am good and sleep to done. So let me explain this. So now docker run, which creates and starts a new container. -d, which runs the container in detached mode. -i, that give the interactive terminal support. Then Redis, it's a base image to create the container, right? Then /bin/sh-c, which runs the shell command inside the container. While true, do echo hello all I am good, sleep for 2 seconds, done. It's a infinite loop that prints the necessary, like it prints the message every 2 seconds. So what will be the result? The result, the container keeps running in the background. Every 2 seconds, it prints hello all I am good. Hello all I am good. So now let me show you the result, how exactly it look now, right? So if I use the command docker logs -ft container 6, so you can see here, hello all I am good. Hello all I am good. Hello all I am good, right? So here -f that follows the logs live, right? -t that shows the timestamp, and container 6 container name whose logs you want to view now, right? So to stop this, you have to use Control C. Fine. Now I am going to discuss some of the commands. Like even you can say that how to access container or how I am going to run a commands inside the container. So which command I am going to use now? Docker execution -it container1 /bin/bash. So Docker execution, it executes the command inside a running container. -I, it keeps input open, that is interactive. -t, it allocate the terminal TTY, and container1, the container name or ID. /bin/bash, it open the bash shell inside the container, right? Now let me use the command called ls, list. I am in the container now. Now I am inside the container environment where I am going to list out a different directories. Like here you can see bin, boot, development, docker, encryption point. These are the different files and directory which are available for us.